And done. Oh, that was a world record. Hey, geometry. For this section, we're going to talk a little bit more about how do you prove something is true or not. Remember, this whole chapter is really on reasoning. We talked about inductive and deductive reasoning. This is going to be more on the deductive reasoning side. The first law I want you to teach you is called the law of detachment. Honestly, I don't know why they call it this, but we'll just go with it. The law of detachment says that if you have a conditional, remember that in a symbolic form, P and then an arrow to Q means if P, then Q. That's a conditional statement. If you have a conditional, like let's say, if someone touches the sun, then they will get a big owie. Okay? Now, if both parts are true, if someone touches the sun, then they will get a big owie. And then I say to you, John touches the sun. What do you know? Well, then John will get a big owie. Okay? So that is the law of detachment. If this, then this. And if I know that this happened, then I know that this part is true also. You got to be a little careful. You can't just flip it around, with proving things. With proofs, you've got to be kind of rigid in your thinking. It's really teaching you a way to be very methodical in your thinking. For instance, I can't just flip this around. I can't just say, oh, I see John and he has a big owie. That means he must have touched the sun. No, because of course you can get hurt doing other things. So it's very rigorous. It starts with P. If I start here, then this. If this is true, then this is true. Okay, so that's the law of detachment. The second law that I'm going to teach you is called a syllogism. The law of syllogism. The law of syllogism just says something like this. In symbolic form, it would say, if P, then Q, and then if Q, then R, and if both these are true, then not Q, then if P, then R. So it's basically you have two conditional statements, and if they're both true, then you can kind of cut out the middleman almost, and you can say, if this, then this. I'll give you a quick example. If you were bald, then you save money on shampoo. Don't ask me how I know that. And if you save money on shampoo, then you can use that extra money for something like golf. Again, don't ask me how I know. But if that's true, so if you're bald, then you save money on shampoo. And if you save money on shampoo, then you can use that money to play more golf. So therefore, if you're bald, you can use that money to play golf more. That would be a valid conclusion, because if this is true, then this, and if this is true, then this, then you can cut out the middle. So if I'm bald, I can use extra money to play golf. Okay, I think that's what we have. We have the law of syllogism. We have the law of detachment. You're going to be using these in your proofs that we're working up to in geometry. Okay?